Now, I want to say that generally, the electrical and electronics engineering have to answer these questions when they want to describe the operation of a system. The first question is that how do these devices work and what are their limitations? Answering to these questions are in the domain of electrical and electronics engineering. In fact, engineers using some mathematical tools and scientific principles try to design the devices for improving our life and solving the most of the problems in the society. Now, here, I want to show you a represented form of block diagram of a smartphone. Let's talk about that, and I want to talk about the extended block diagram of a smartphone. Let's look at here. First of all, I said that at each block diagram, we will have input. This input in a smartphone, which is called E of t, is our energy. But sometimes in smartphones, the energy is in the form of acoustic energy, like our sound. Then this energy or this signal is fed to the microphone of computer, of a smartphone, or also computer, doesn't matter. But in this case, we are talking about the smartphones. Now, we can get a waveform called x of t. This x of t is an analog signal or analog waveform. But we said that our systems are digital systems. For this reason, we need to convert the output signal of microphone to the digital. For this reason, we need to have another block like ADC. What is this ADC? ADC is analog to digital converter. Analog to digital converter. So, what is the task of this block? Actually, this block converts the x of t, which is an analog waveform, into the digital form. In this case, the digital form here is speech samples. Okay, now our signal is ready to apply into the computer for doing some process. Now, because we produce a digital signal, now we can give the signal into the computer for processing. So some process is done in computer and we can get again the output of this signal, which is again a digital signal but is transmission code. This signal contains some information that is done during the computer block. Some process is done on the signal to get the Y of YI as a transmission code. Now, this actually signal is sent to the destination device, another device that we want to have communication with them, and through antenna before the antenna, we need to convert again this signal to the analog form, because we only understand and perceive the analog form of energies. Again, this is our digital to analog converter. After that, using the antenna, now here we have analog signal again. We have antenna here, and also we have different type of energy that we can understand. For example, if you talk here, this signal is analog signal. Again, this signal is enhanced, for example, form of this signal with the enhanced form. Here you have digital form of signal. Again, here you will have digital form, but some information include this form of signal. And here again you will have analog signal, which is different type of energy. For example, here is your sound. This signal, which is an acoustic energy, this signal is vibration, which is a mechanical energy. This process is done through the smartphone, that we can hear, or your voice and two person can hear themselves voice, and so on. Generally, this is the extended block diagram of a smartphone that I tried to show you. Yes, again, I explained everything that I'm talking here. As you see here, I talked about the input, the sensor, ADC converter, computer process, DAC actually block, and at the end I talked about the actuator. Okay, let's watch this video. This video will help you to understanding the block diagram that I talked about that. Okay, when we start to talk with our smartphone, let's look at what happened inside of the smartphone. Okay, this is the microphone of the cell phone. When you speak in your smartphone, this microphone is understand your voice. Now look at what happened. Okay, as you see here, the analog signal is coming to the microphone. This is actually the digital board of the microphone. Inside of this board, which is called PCB, actually, printed circuit boards. Inside of this PCB, you can see a ADC microphone and analog to digital converter. As you see here, analog signal is converted to digital form. This digital signal contains your voice, but in digital form. As you remember, I write in the block diagram, I said that sound sampling, speech sampling. This is contain your voice information, this digital. Okay, this signal is sent to the antenna that is in your actually a smartphone. This is the antenna of your smartphone. This digital signal is sent. Okay, this antenna will send your voice information, that digital signal, via electromagnetic wave to the other device. But be careful, this is an electromagnetic waveform. Actually, this digital signal include this electromagnetic wave to transmitting between two devices. But this video will show you that we cannot directly have connection and have communication with two different smartphone devices because of some problems. Okay, actually, these electromagnetic waves transmit the zeros and ones, but some characteristics. What is the characteristics? Okay, at this electromagnetic signal or waveform, the zeros, the frequency of the zeros and one are different with together. For example, when we have one, it means that our frequency is high, and when we have zero, it means that our frequency is low. In this case, at the destination section of this communication network, this receiving data can be detected that how section of signal is contained one and what section of signal is contained zero. Okay, this electromagnetic wave is transmitted to the destination point. But as I said to you, this electromagnetic wave cannot travel directly between two different sections because of some problems that cause the strength of this electromagnetic wave is reduced. Some electronic devices, some other communication networks and constructions are the cause of that this electromagnetic wave strength is reduced. So let's look at here what happened and what can we solve this problem. Okay, to overcome this problem and this issue, we used some antenna at the different type of different location of our country or in the world. Actually, all of these antenna receive these electromagnetic waves from the start point and send it to the destination point of system. And also this antenna use the cellular technology. As you see here, all of these towers is connected with together in our board. When we locate to one of these cells, for example, is our location. When here we want to talk with the other person which is in this location, we send these our signal electromagnetic waves into this tower, and this tower sends the electromagnetic wave into this tower. Look at here. Yes, all of these towers are connected with together with optical fiber cable. The waveform is transmitted to the destination point. This is the destination tower or destination point. Now, this destination tower radiates this wave to the destination smartphone. Now here, this signal again, okay, now our smartphone received the signal, and again here, we need to convert this digital signal. This electromagnetic wave contains the digital information. All of the information we include in the electromagnetic wave are zeros and ones. But we cannot understand these zeros and ones. For this reason, first of all, we need to convert this signal that comes from the other smartphone to the analog phone. Yes, as you see here, through this device, which is analog to digital to analog converter, we convert the digital form to the analog. Now, for this reason, during the speaker, we can hear our friend's voice. As you see, we talked about the devices like smartphones, computers, and other devices in digital form. But as you see, these devices is actually produced using connection that some components. For example, microphone, ADC, computer processors, and actuators, sensors. All of these elements are components of our devices, which are connected with together and produce a device. Component connected with together and produce device. Now, these devices which are connected together contain a system, and more than one systems when connected with together produce the network. This is 4-level size of complexity that each of to know and have information about them. What kind of component do we have in the electric and electrical engineering? We need to know how these components can connected with together to make a device, and what kind of electrical devices do we have in the digital world, and how these digital devices is connected together to make a system. For example, suppose that you have an electrical system, you have a communication system in the, for example, Azerbaijan country. Actually, suppose that in Baku city, you have a communication system that your devices are connected with together to make this system. And this system are connected with together to make a network of Azerbaijan communication network. And also these networks can connect to the other countries that make the wider networks with together. At this level of complexity, we need to have information about all of them. What happened in the network of the system? What are the problems of a network? what is the limitation of systems, and how can we produce and make a device using components. All of them are our tasks that we will learn about them during these 4 years in Bachelor of Science, actually. Again, if we talked about the components, you see that, for example, in the case of a smartphone, cameras, microphone, and processor are our components. In a robot, a sensor is kind of component. In computer, in your laptop, look at your laptop, for example, your RAM, your CD-ROM, your motherboard, your CPU, your keyboard, all of them are components of your device. And your device is computer. This computer is connected with together to make a system, and this system can actually connected with together to have network, for example, internet. And also devices or computers, smartphones, and all of the other types of devices. And I gave an example about the electrical system and communication system as a kind of system, and also networks, as I talked about that in our digital age, we use networks like internet to have communication with together from this point, from actually in our country to the other country. We can talk about that via this network. Also, this network has some its problems. For example, we cannot understand which system or which device is connected or which device is not connected. When a device want to connect to our network and when a device want to disconnect from our network, all of them can be distinguished, can be analyzed, and we need to have information about all of these problems and try to solve them. These are some difficulties of networks problems. As a last topic in this chapter that I want to talk about, that is Moore's law. What is Moore's law? Actually, Moore was actually a scientific man that observed that the number of transistors on a computer chip doubles approximately every 18 months. He watched that in 1971, the number of transistors in a computer was 2,500. So you make a relation between these numbers and years. After approximately 2 years, for example, in 1973, he observed that the number of transistors doubles to the 5,000. Now, using this formula in these days, we can find the number of transistors at each computers according to the year of, for example, 2000, 2020, 2030, and all of the years that we want to know about the number of transistors in our chips. So all of the most important and companies which are related to the computers and producing the microprocessors obey these laws. This law represents that, for example, in 2020, how many transistors do we need to have in a microprocessor?